Okay, so we're going to go ahead and do limiting reactants practice today. It is similar to stoichiometry. It is stoichiometry. We're just adding some more steps to it. So we're going to be able to find out some other information using the same steps that you've been using. So I don't think it'll be too much of a stretch from where we've been. And I'm going to go ahead and go over the entire first question on the first page of your assignment. So there are slides on this on Canvas. So if you do better reading it and seeing the examples on slides, so you can go back to it, that's there. There's also another video from 2 years ago that's posted on the assignment tab that has other examples of stoichiometry with limiting reactants practice. So if this ends up not being enough to help, then check out those resources. Otherwise, just keep trying, you'll get it, and you can get a hold of me when I get back to school. So we're going to go ahead and do the first one. So if you guys are looking at your assignment, you should have paper copies today in class. So we are going to find out a couple of things. Whenever we have a chemical equation, right, we know that we're going to start with a certain amount of both of the reactants, and then that's going to give us some products out of there. So if you think about your lab from last class, you had hydrochloric acid and sodium bicarbonate. So if you started out with, like if I handed you 10 grams of sodium bicarbonate powder, but I only gave you 1 dropper full of hydrochloric acid, that's obviously not going to be enough to fully react all of the sodium bicarbonate. Okay, so in that case, one of those substances is going to limit the reaction from continuing. That's obviously going to be the hydrochloric acid because there's not enough to fully react the rest of it. So we can figure that out mathematically ahead of time. A lot of times this is used in industry to figure out, how much do they need to purchase to make a reaction happen? How much product are they going to produce? Pretty useful in real life. So this is also another thing that I know is on the MCAT. So anybody that's looking to get into medical school someday, you guys want to be good on stoichiometry. So we're going to go ahead and get started with the first part of this. So you'll notice on this sheet that you guys have like 3 parts to each question. So the first thing you have to do is figure out which one of these is going to be your limiting reactant. Once you figure out which one the limiting reactant is, that's what you'll start all of the rest of your problems with for like B and C. And then a lot of times we can reuse, like recycle some of these numbers in here. So it is a lot of writing, but you're not doing a lot of new things with this. So once you get some of your numbers written out, you can kind of reuse those values over and over again. It doesn't take forever, even though it looks like it. So we're going to start with the first one. Which of these is the limiting reagent? If you notice that on this sheet, it tells you that you start with 30 grams of ammonium nitrate and 50 grams of sodium phosphate. Okay, so we have 30 and 50. 30 of this one, 50 of this one. Okay, so that's what you're starting with, as if you were doing it in person. So what we're going to do is we're going to take the amount, the mass that's given, and convert that of the reactant into one of the products. Which product you choose to convert these into doesn't matter, but you have to convert them both into the same product so that you can compare to see how much could be produced if you had that amount to start with. I think that'll make a little more sense after we do an example. So let's just go ahead and do one. So for this question, I went ahead and chose the sodium nitrate to convert it into, simply because I felt like it was probably easier to add up. Doesn't really matter. So on this first one, we're going to start out with the 30 grams of ammonium nitrate. Okay. When you're writing these on your paper, you're going to want to start all the way on the left-hand side and write small because these will carry across your page. All right. So typical stoichiometry, we know that whatever unit we start with in this part of your table, that unit has to come over and down, okay, every time. So the idea is that when you multiply and divide this at the end, that you're canceling those units, and that's what we want. So the grams of ammonium nitrate has to be the unit that goes here. All right, so I'm going to go ahead and write that in. Grams of ammonium nitrate. I'm just going to go ahead and write in some of my units underneath the numbers on this just because this board's not very wide. So now we can convert the mass into moles. Same mass to mass stoichiometry problems we were doing last class and class before. So we know that the molar mass of anything is going to be equal to 1 mole. So we're just going to say 1 mole of the ammonium nitrate is equal to how many grams? So that mass, if you are having trouble remembering, you're just going to look that up on the periodic table. You're going to look up each of those masses, add them all together to get a total. So this one happens to be 80.1. Okay, so we have 80.1 grams of ammonium nitrate is equal to 1 mole. So now you're in moles of ammonium nitrate. So moles of ammonium nitrate has to come down here and be the unit. This is our opportunity to change, to convert from talking about one substance into another. So like I said earlier, I'm choosing this product to convert them both into. Now we're going to look at the mole ratios from the balanced equation. So this equation is balanced already. You can see that there's 3 moles of the sodium nitrate, 1 mole of the ammonium phosphate, 1 mole of sodium phosphate, and 3 moles of ammonium nitrate. Okay, so we're looking at the ammonium nitrate. We know there's 3 moles of it. And we are converting it into the sodium nitrate, which there are also 3 moles. We want to take this all the way to the mass so that we can compare the amounts of product that are being produced. So we're going to pull the units down again. So we have moles of sodium nitrate has to come down here. We know that we can convert moles into mass. So we're going to go ahead and put 1 mole of sodium nitrate. And we're going to find the mass of sodium nitrate the same way you would have found this value, which ends up being 85 grams. Okay. Now at this point, you can put it in your calculator and solve. Okay, so just another reminder, you're multiplying all the values on the top and you're dividing that by, you're multiplying all of it on the bottom and you're dividing the two. Okay, so we're going to get an answer of 31.8 grams. Okay, so this is not the answer to part A. That's not your limiting reactant. It could be, we don't know yet because we haven't compared it to the other substance. So what this information is telling you is that if you begin with 30 grams of the ammonium nitrate, you can produce 31.8 grams of sodium nitrate. So now we have to use the other reactant, which you'll notice is written here in this first question. So it told us we had 30 grams of ammonium nitrate, but it also says that we have 50 grams of sodium phosphate. So now we have to do this again, but we're starting with the 50 grams of sodium phosphate, and then we're still going to convert it into this sodium nitrate. So let's start that again. So we're going to have 50 grams of the sodium phosphate. Okay. So again, following the same pattern, we're going to bring down grams of sodium phosphate, and we're adding this up from your periodic table. Okay. The mass is equal to 1 mole. Okay. Now that we're in moles, this is our opportunity to use the mole ratios from the balanced equation. So we know that up here we have just 1 mole of sodium phosphate, and we have to convert it into the same product to get a true comparison between the two. So we're going to go ahead and convert this into the sodium nitrate again. So we have a 1 to 3 mole ratio. So you're going to have 1 mole of the sodium phosphate set equal to 3 moles of the sodium nitrate. So now you'll notice that the rest of this problem is going to look just like the ending of this problem because it's all the same numbers. You're converting it into the same product. So as long as you calculated this value correctly, it should be fine to recycle that and use it again as you work. Anytime you need to put something in for sodium nitrate. So again, we're going to have 1 mole of the sodium nitrate, and we're going to have the 85 grams on top. Right, so again, you're going to do your calculations. It's going to tell you that that is 77.8 grams. Okay, so what this is telling us is that if we start with 50 grams of the sodium phosphate, we will produce 77.8 grams of the sodium nitrate. Okay, so now we can answer question A, part A of this question. Which of these produce the least amount of product of the same product? Obviously, this is the smaller amounts. So that means that the 30 grams of the ammonium nitrate is our limiting reactant. Okay, so that is the answer. So you would just write that out, that 30 grams of the ammonium nitrate is the limiting reactant. So you will end up with extra. You'll have excess reactant of this one left over, and we're going to get to that. That's going to be in part C. So that is part A. Okay, so I took a second to pause that so I could write this up here. This would be your answer for A. You had to do this work ahead of time in order to figure that out, but this is going to be your answer. So sometimes it does correlate where the lesser mass that you're starting with ends up being your limiting reactant, but not always. So you can't just look at this and say, well, obviously 50 is larger than 30. You can't just say that and decide on your limiting reactant off of that information alone, because depending on the moles and the masses and everything, that just may not be the one that limits your reaction. Okay, so let's get started with part B. So now that we've identified our limiting reactant, we know that it's the 30 grams of ammonium nitrate. This is the value that we're going to start all of the rest of our problems with for number 1. So the second question is asking us to figure out how much of each product can be produced using this limiting reactant. So if we're in a lab and in a situation where you're given 30 grams of ammonium nitrate and 50 grams of the sodium phosphate, how much can we produce of these products? What you did on part A, when you figured out which one was your limiting reactant, you already figured out how much of the sodium nitrate could be produced. So the answer on part A, that you got 31.8 grams of sodium nitrate, that's the maximum amount you can produce there. So you don't have to redo that work unless you want to. I usually do just because I like to see it all written out, but you don't have to. So just don't forget to include that value in the final answer. So since we already did this product, we now have to calculate how much we will produce of this product. So we're starting with the limiting reactant. We're going to convert it into the mass of ammonium phosphate, and that'll tell us how much can be produced. So this follows the same trends as before. We have the mass of ammonium nitrate, so the mass has to come down of ammonium nitrate. So we're going to have 80.1 grams. Okay, we know that's equal to 1 mole. Okay. Now's our opportunity that since we're in moles, we can use the mole ratios to convert it into our other product. So again, we have 3 moles of the ammonium nitrate. And we have 1 mole of the ammonium phosphate. And yes, I know it's kind of a pain to write out the entire unit with the formula every single time, but it is necessary so you don't lose track of where you are, and we can read through this problem and we understand what's going on. So if you're just writing numbers down or you're just saying 30 grams and 80 grams and 1 mole, it's not as meaningful. So if someone else is looking at that, they're really not going to have any idea what's going on. And that's kind of the whole point of science, is that it can be repeatable. So now that we're in moles of the product that's desired, we're going to go ahead and pull that all the way out to mass. So we're going to put 1 mole down here. And then you would get the mass of ammonium phosphate. You're just, again, finding each of these on the periodic table, adding them all together depending on how many there are of each of them. So this one's going to be 149.1 grams. Okay. At this point, throw that in your calculator. It should tell you that you're going to produce 18.61 grams of the ammonium phosphate. Okay, so a completed answer would look like this. So when you write out your answer, make sure that you are including both or all of the products. As you guys know, sometimes there are 3 products that are produced. There could be 1. There's variations, okay? So if there is more than 2, you're going to have more than 2 values here. If there is only 1, you're only going to have 1. So in this case, we know that the reaction is going to produce 31.8 grams of sodium nitrate and 18.61 grams of ammonium phosphate. So I'm going to go ahead and erase this, and we will move on to part C. Okay, so now we're on part C, which is asking how much excess will you have of the excess reactant after the reaction is over. So we know that because this is our limiting reactant, we're going to use all of it, and all of this will be used up. There will be none left. But since there was more of this, we're going to end up with some leftover, and we need to figure out how much that'll be. So we're going to go ahead and take your limiting reactant again, and we're going to go ahead and convert it into the mass of the only remaining part of your equation, so the other reactant. Okay, so the previous problems, you were going from the reactant to the products. This problem, you're going from your limiting reactant to your excess reactant, whichever those may be in your problem. So I've went ahead and started this problem out. We went from the 30 grams to the mass to the mole. Here we're going to use the mole ratio, and as you can see from the balanced equation, we have 3 moles of the ammonium nitrate for every 1 mole of the sodium phosphate. So we're going to go ahead and fill that in. Okay, and then we have 1 mole up here. Right? And just like the others, we're going to go ahead and pull this all the way out to mass. So we're going to convert the ending here all the way out to grams. So we have 1 mole of the sodium phosphate is equal to a mass of 164 grams. Okay. So when we get that calculation, it's telling us that we're going to have 20.5 grams of the sodium phosphate used. Okay, so what that's telling us is that in this reaction, you'll use all 30 grams of the limiting reactant, but you're only using 20.5 grams of the excess reactant. So you have to look back at the original question and see that we started with 30 grams of ammonium nitrate, we know because that's our limiting reactant, but there was also 50 grams of the sodium phosphate. So we have to find the difference now. So if we started with 50 grams, we're going to subtract the amount we used, and that's going to give us our final answer. So this would be your final answer for this question. We're going to find the difference, like I said, from what you started with. We started with 50 grams of sodium phosphate, and we now know by doing stoichiometry that we're going to use 20.5 grams. So the remaining amount is going to be 29.5 grams. So the answer to part C would be this, so that you're going to have the 29.5 grams left over or in excess. So that's all of it. So I know that probably seems like a lot. It does for everyone when you first get started, but after you do 1 or 2 of them, it's going to come really naturally. It's really just exactly what we've been doing all of January. So try not to stress about it too much. Give it a shot. You'll notice that at the bottom of your homework sheet, there's numbers, okay? So those are going to match up with the numbers that you should be getting. The only exception to that is if you choose the other product, the opposite product from what I chose to convert into, your number, your very first number, first or second, may not be exactly the same. You'll still get the same limiting reactant, and so that won't change any of the rest of it. So If you choose, like if you did this whole problem, but you chose to convert it into this product at the very first step, it's fine. It's still going to tell you it's the same limiting reactant. If you want it to be exactly the same as these values, so you can kind of check your work as you go, on question number 2, you need to convert it into the calcium phosphate on part A. Question number 3, you only have one option. It's going to be the only product that's listed, okay? So you only have one thing to convert it to there. And then on question 4, you want it to match the numbers at the bottom. I went ahead and converted it into silver because that was easy, okay? So this complete worked out key is also on Canvas. I would encourage you to try it on your own first. Try to work through these, check your answers as you go, talk to the people around you. And then, if you get home tonight and you're struggling, the key is online, so you can check that out. If you have any other remaining questions, stop by tomorrow. You can come by ACT Lab before or after school, and I will be here to help you out.